Morning section, the main section, there were technical issues. We could not stream at all, but this room is much better. Hopefully, if anybody's watching this on a recording, as I said, we'll go ahead and get those resolved or change rooms if we have to. But anyway, I'm Dr. Chris Burke. Welcome to Computer Science 2. This stream is for the honors section. But anybody watching it from the main section online or after the fact, just go ahead and ignore anything I say that only pertains to the honors section. But otherwise today we're going to give a quick course introduction and then get right into the material. Let me go ahead and bring it over here. There we go. So just a broad overview here. We're going to give a broad course overview, talk about it in philosophical terms. And then we're going to get into the nitty-gritty details, the labs assignments. You'll note here that I do not have a bullet point for exams, quizzes, or tests or anything like that because there are none. This is a 100%, nearly 100% project-based course. It's all formative. I forget the difference between the two, but it's not tests, basically. It's project-based. We're going to go through what each phase entails. The design document that you're going to be maintaining throughout the process, whether or not you can collaborate and how you should collaborate with other people on the project, and then the resources, of course, that we're going to be providing for you. Thank you. Online, if you're online, go ahead and feel free to use the chat. I am paying attention. Very broadly here, at the end of Computer Science 1, you should have come to the realization, or the skills that you should have acquired are that you can approach a reasonably complex problem, design a top-down solution. That is, you can take the problem, you can break it up into smaller and smaller chunks until that's a single line of code, or it's a single function that's in the standard library or something like that. And then you can implement it in actual code in a high-level programming language. This is exactly how computers work, right? Computers are dumb. They only do exactly what you tell them to do. They're not problem solvers. People are problem solvers still. Despite the fanfare that you might have heard about things like Chat GPT or whatever it is, we're not in Star Trek yet. Probably not within my lifetime, depending on how long I live. Probably not even within your lifetimes, right? Programs only automate solutions, right? They're very good at processing a lot of data very quickly as long as you tell them exactly how to do it. But telling them exactly how to do it, there's the art of problem solving. Because by the time that you've sorted out a complicated idea into little steps, this is Douglas Adams, even a stupid machine can deal with, you've certainly learned about it, about something yourself, right? If you can break a problem down into such small parts that each part is solvable, then you've solved that problem. Right? By the end of this course, you should turn that around and ask yourself questions when you're approaching a problem. Instead, you should ask yourself, what entities should I create? What classes should I use to model this problem? How should those entities interact with each other in order to solve the problem? And what data structures or algorithms could I pull off the shelf in order to solve the problem trivially, right? All I need to do is pull off this data structure, put stuff in, take stuff out, and it's magically sorted, right? That's what heap sort is, right? You have to write dumb code. Put stuff in, take stuff out, but it's magically sorted, right? It's not magic, it's the actual data structure. And that goes to the next quote here, which is not Douglas Adams, but Eric S. Raymond. Smart data structures and dumb code work a lot better than the other way around, right? You can write a lot of smart code. You can write thousands of lines of really smart, clever code, but I can beat you by simply pulling off one data structure off the shelf, writing 2 lines of code, and I've solved the problem, right? It's all, that complexity is hidden inside the data structure itself and the nature of the data structure, right? Here's an approximate schedule. For weeks 1 through 3, we're going to get started with Java in the main section. Since many of you are coming from 155H, already having Java, we're going to be doing Python. If you're coming from 155E, only having C, don't worry, you're not sunk. Just the only thing that I would say is maybe watch the live streams, watch the 14 pre-prepared videos I have on an introduction to Java, do the first 3 labs in Java, and do the first assignment in Java, right? Forget about Python if you already know Python, right? That goes for the same if you feel that you did have Java at some point, maybe in high school or something like that, but you kind of feel that you're not solid on it, then go ahead and do the first 3 labs in the first assignment in Java, right? I'm not going to police that. The hand-in will accept either version. Right? Then we get into object-oriented programming in Java in particular. Java is not the only object-oriented programming language. It was not the first. It's not going to be the last. To an extent, Python has object-oriented programming principles. To an extent, I'll say. But it is certainly not an object-oriented programming language like Java is, right? Then we get into database connectivity, database design. And we'll learn yet another programming language called SQL, structured query language. It's used to access databases, relational database management systems. We will learn vanilla SQL. There are lots of dialects of SQL out there. Microsoft has one. Oracle has one. Basically, everybody tries to add a feature on it to get them to people to use their products. And then you've got something called vendor lock, where you're stuck with them unless you want to rewrite everything from scratch. I'm not going to do that. I'm going to start with vanilla SQL, only stick with vanilla SQL. It'll work on any database management system. The ones that cost millions of dollars from Oracle down to the ones that are free to use, which we'll be using MariaDB. Then we'll get into, that marks the 2/3 of the course. Then we'll transition into DSAs, data structures and algorithms. We'll look at list data structures, algorithms and algorithm analysis, big O analysis. We may revisit searching and sorting, stacks, queues, binary search trees, and heaps. So data structures and algorithms are the second, third, or thereabouts of the course. Your assessment for this course, your grade, is based on labs and assignments. Labs are about 20% of your grade. Right? They are weekly, except for the last week. You get that off. But there are 14 labs total. We will drop your lowest one. Okay? So we only grade 13 labs. At 20 points each, that's 260 points each. Extrapolate what 20% is, and you'll find that there are 1,250 points about for this course. I don't know exactly what it is. Pull out a calculator and count them up if you want. Otherwise, starter code, the way that labs work is that starter code is provided on GitHub. This is true for both the Java version and for the C version. I've got to get out of 155 now. The Python version. In fact, the legacy PHP version, we took a vote in 155H last semester, and everybody said, let's go move over to Python. I said, all right, fine. But I left the PHP version in there. If you really want to learn like a 4th programming language, PHP, you could go ahead and check that out as well. But we won't be grading it. Their grader's not set up for that. Anyway, we provide you with starter code. You have to go through, finish that code, and then we also provide you with with a JUnit tests. This is a test suite where all you have to do is click a button and it reports, I ran 20 tests. These tests passed. This test failed. Here's how it failed. This is the expected output. This is your output. Go back and fix it. Right? You can run that as many times as you want because it's part of the project that you check out from GitHub. Once you've done that and all of them are passing, then you hand that in and you've got full points. Unfortunately, if you've got 19 test cases that are passing and one that's failing, that's not enough, right? That's not complete. There's no partial credit for this in this course because it's all automated. On Thursday morning, I'm just going to simply press a button, run a script. It will run everybody's JUnit tests and automatically update the Canvas gradebook. Right? So if it passes 19 out of 20 tests, but that one last test case fails, unfortunately, it's a 0. Right? So make sure that all of them are passing, everything is handed in, etc. Again, we'll drop your lowest one. So if you screw up and get that 0, then fine. Or at the end of the semester, I wouldn't recommend it, but at the end of the semester, if you've got 13 perfects, and you just want to take that second to last week, we call that the penultimate week, then you can go ahead and not do it, but I wouldn't recommend it. Right? Some of them are fun. Right? You can work in person or via Zoom if you're online. You can go. There is a specific lab section that you should go to. You can partner up with somebody and do the lab. If you want to do it beforehand and just get it done and never go to lab, that's fine too. If you want to do it alone, that's fine. If you want the LAs in the lab to team you up with somebody, that's fine too, right? You just need to decide how you're going to approach that and how you're going to approach the material. For lab 1, I've got a complete video walkthrough of that I've been posting to Piazza. You can go ahead and follow along on that just to get set up. For the Java version, I don't have one for the Python version. You all voted for Python, but I did the first assignment and the 3 labs, and I do not have a note set, so we'll be making a note set as we go along here. By no means am I a Python expert either, so if any of you do have Python experience and want to yell at me that I'm doing something wrong, please do so. Note that however, that we will be exclusively using Python 3, none of that 2 nonsense, okay? Assignments are 80% of your grade. Assignment 1 is a standalone assignment. It's 3 basic programs, not in PHP, but Python. All right, sorry, I thought I fixed them all, but it is Python. It's individual, however, no collaboration, no partners. This is your litmus test on whether or not you've properly prepared for this course. What you should do is you should look at that Java version or the PHP or the Python version, whichever one that you're not doing, or it doesn't matter, they're the same one. But would you be able to do that in the languages that languages that you're already familiar with? If so, you're good to go for this course. Right? We will be using Java throughout the course after week 3 and exclusively in the main section. But make sure that you're up on it. Right? Assignments 2 through 7 are an iterative project. Each phase builds on the previous phase. So don't think I'll just go ahead and skip phase 2 because I'm just shooting for a C in this course. That ain't gonna work, right? You will need phase 2 in order to build phase 3 because it builds on each other. The first phase is just basic object design and EDI, electronic data change interchange, where you're creating your objects, and to make sure that your objects work, you load them up from a flat file, a CSV file, and then you create your objects and then you dump them to a JSON or XML file. For this course, it's going to be both, because that's another difference between the main section and the honors section. Every assignment is going to have most assignments are going to have some bonus points available, 10, 15% bonus. Those are going to be required for the honors section. Right? For example, in assignment 2 and 3, you have to write your own test cases. You have to provide a file. For this course, for the main section, if you turn those in a week early so that we can use them to grade everybody else, that's worth bonus points. For this section, it's required. So you're going to have to turn in those test cases a week early in order to get those full points. I make like 2 or 3 test cases myself, and then I crowdsource it to all of you. And then we take your test cases, we fix them if necessary to make sure that they're correct, and then we put them into the grader. Right? Or if they're just beyond fixing, then we throw them out. Right? Then we go into database design. The next phase is you load up data from the database instead of that file, that CSV file. And then you you save data to the database. And then the last one has you doing a list ADT, a list implementation, and integrating that with your project. The last assignment is completely written. It's theory-based because the last third of the course is that DSA, that data structures and algorithm. So you'll be handing out a PDF. You can handwrite your solutions. Most people do. Take a snapshot of it and then hand it in that way, or convert it to PDF or something, right? Or type it up if you're really bold. Go ahead and type it up. Do not use Word. You'll waste more time typing things up in Word than you would if you learn LaTeX or Markdown or something. Right. Again, it's project-based. It's a multi-phase themed project. The theme this year is you are writing an invoice management system for a business-to-business farm agriculture supply company. I think I couldn't think of any clever name, so I just called it Farm Mart, where I take out one of the M's, right? Clever, huh? It's not the financial asset management system thing, and I didn't update that either. But anyway, each phase is graded based on correctness and design, so see the rubrics on how exactly we're going to grade for it. The rubrics are embedded in each one of the handouts. Along with each one of these phases that we already just previously talked about, you're going to be handing in an IEEE formatted design document. We give you a Word template. We also give you a LaTeX template. If you're so bold as to want to learn LaTeX, you can use that as well. But this is a living document that you maintain. The idea behind this is that it's going to be due 1 week before each phase. That is your opportunity to get your design down on a piece of paper and get our feedback about your design, right? Because then the following week, we'll be as quick as possible on our feedback. But you'll say, no, don't do that, because if you do that, then later on in phase 3, you're going to be fighting that design, right? We're going to be looking at your design, and as long as it's a coherent enough living document, design document, that we'll be able to say, okay, we understand what they're going for here, and they're on the right track, or they're on the wrong track, or something like that. We'll give you tips and we'll give you feedback so that you can improve that. That design document is a draft. It is graded in that you hand something in that's coherent and not just garbage or the template itself, and we'll give you your 5 points. Only the last one is graded, right? Full, the 150 points or whatever it is. But only the final design draft contents count. We will talk about that closer to the actual first due date of one, like after we get done covering Python, in which I will have a representative from the Writing Center come over, and we usually give a dual lecture. I'm just telling you all this stuff. It's highly encouraged to work in pairs, except for that first homework, right? The assignment 1, no partners, no collaboration. You got to prove that you're ready to take this course, right? Prove to yourself mostly. You can but beyond that, labs and everything after that, you are highly encouraged to work in pairs. Not triples, not 4s, not 5s, but pairs. You can work alone if you want to. If you so choose, you can work alone throughout the entire semester. You can discuss with other pairs or other people the project at a high level, like, well, I used inheritance to create 2 different customer types because I thought this way. And, oh, okay, yeah, I did that too. So we're both on the right track. Or I did it this alternative way because of this. That's very, very high level, right? Don't get down into the nitty gritty. Your collaboration, however, should be a shared equal work, right? Don't just say, you do the even labs and I'll do the odd labs. That ain't gonna work. Or you do this part and I'll do that part on this one phase. No, you should be collaborating. I mean, you can collaborate and then go off your separate ways and say, all right, you're gonna be doing that part and you're gonna be doing that part, but we already collaborated on how it's gonna go, right? Then you go off and you write your individual parts, you merge it back into GitHub. You should be using Git. Make sure that it is that it's private though, and that's okay as well, right? But don't just let one partner do all the work. Don't let one partner mooch off of you, right? That's not shared. That's not equal work. If that ends up happening, it doesn't generally end up happening, but every so often it will. Feel free to break up with them, right? You need to develop those soft skills, those communication skills of, look, this partnership isn't working out. This reason, that reason, that reason. We need to separate, or I need to see you be doing this stuff over here, or I'm going to have to go my own way. If that's so, fine. Just go ahead and break up, right? You are not married to this individual. Even if you're married to that individual, you can still break up. It's called divorce, right? Anyway, you need to develop those teamwork and those soft communication skills of expressing yourself and listening to another person, right? And basically conflict resolution. Again, partners can mooch, they can flake out, they can disappear. Choosing to work in a pair means that you end up being responsible for both yourself and your partner. Now, what if I were to allow 3, right? Now the complexity of that dynamic goes up an order, not an order of magnitude, but n squared, right? In fact, this is something that we might discuss later on. There's a book called The Mythical Man Month, in which the idea is, okay, this software project is estimated to take 3 months with this team of 5 people. I'm going to go ahead and put a team of 10 people on it, and it's only going to take 1.5 months. Nope, it ends up taking 6 months. Why? Instead of the original 3 months with just 5 people. Why? Because the number of interactions, right, the number of conflicts, the amount of communication goes up by order of, not an order of magnitude, but order n squared, right? So more people does not necessarily mean better results. Colloquially, you call it too many cooks in the kitchen, right? You can't move around because you're always bumping into somebody, right? So do not undermine the learning experience of your partner by allowing them to mooch, right? Maybe make sure that you're using Git, that you're pushing things back and forth. Don't be handing a thumb drive back and forth or using Dropbox or whatever it is nowadays. Use Git, use proper tools, right? And if you're going to do this, make sure that you pair up in Canvas. Again, not for the first assignment though. Keys to success, start early, right? In fact, what you should do at the end of the day is you should go home and look at assignment 1 and ask yourself those questions. Would I be able to do this in Java? Would I be able to do this in C? Would I be able to do this in whatever? You'll find that the answer for most of you is yes, because I don't like work either, right? I just took some of the familiar assignments from last semester, some new, right? What is it? Something borrowed, something old, something new, something blue, right? So I just borrowed some from last semester, like I think it's from the first exam, like estimating corn silage, right? I'm not, despite the theme of the project being agribusiness, and despite that assignment, I have no idea. The last time I was on a farm, I was detasseling in junior high, so I know nothing about agribusiness. Don't ask me anything about it. Make sure that you're starting early. Have a good, well thought out design on paper. That's the purpose of your design document. Again, nobody's going to turn in a good draft, the first draft. That's why you draft. That's why you do a second draft, a third draft, a fourth draft, and you improve it along the way. Make sure that you're using that design document opportunity for feedback to its fullest. Design your test cases before you even start coding. Again, for this section, you're required to do that a week ahead of time. Right? Use proper debugging techniques. All right? Use a proper debugger. I'll show you how to do that in I won't show you how to do that in Python, because I don't know. I don't know how to do it in VS Code Online. Darn it, that's something I should probably look up. Anyway, I'll show you how to do it. I'll review how to do it in Eclipse. Right? Smart data structures and dumb code are a lot better than the other way around. Keep that in the back of your mind. Right? Always be looking for shortcuts, because that's what you should be doing. Right? That if you can take 100 lines of clever, smart code, and you can condense it down to a one-liner by using an off-the-shelf algorithm or an off-the-shelf solution, do it. Right? Beware of technical debt. Right? So colloquially, you say if you don't have time to do it right the first time, then you're going to have to find time to do it over. Right? That's what technical debt is. That if you do it, if you just throw a bunch of code out there, right, without any forethought or any design or forward thinking, then you're going to accrue technical debt. If you have a bad design on phase 1, you're going to be fighting that bad design all throughout the entire process. Or you're going to go back and refactor it and fix that design so that you're not fighting it. Right? Either way, you've taken out a loan on your time, your future time. That's why we call it technical debt. If you take a shortcut now, right, yeah, you're saving an hour of planning, right? But then you're going to pay interest on that loan later on, 10 hours of redoing it or 10 hours of fighting it, right? So make sure that you are thinking about design first. In fact, you'll find in the rubrics that the vast majority of the points for this course are on the design parts. 60, 70% are design, and only 30 or 40% are on correctness, right? Attend office hours or help hours early, right? Let me show you the schedule already. Where is it here? Getting help, there we go. It's the same schedule for both. Feel free to go to any LA at all. It's basically a pool of resources here. But you'll see all the blanked out areas. Those are the lectures and the labs, so there's no office hours there. But all of the little colorful areas you'll see, that's when a learning assistant is holding their office hour, their help hours in Avery 15. Right? You'll notice here, though, very few help hours on Friday evenings. Why? Nobody likes to work on Friday evenings. They signed up for these office hours. I didn't say don't do Friday evenings. Nobody ever signs up for hours on Friday evenings because they don't want to do it either, right? But that's when everything is due, right? So go early, right? And even if you went in the Friday afternoon, you're going to find it packed with those folks that didn't heed the advice and didn't go early. And you've got two LAs. Who are they? Kevin and, I can't read it. Kevin and Ethan, looks like, are there on Friday afternoons. Good luck to them. Right? All right, so back over here. Where were we? Darn it, lost my place. All right, so go early, ask questions often, etc. Use Piazza to its fullest extent, right? You've all seen Piazza hopefully before. If not, I post a question here anonymously. Post a question identifiable to just a private question just to the instructors. We usually have like a 4 or 5 minute average turnaround time on answers. You feel free to answer other people's questions. Every week I do a retrospective. Every week, at the beginning of every week, I tell you what we're doing that week. For example, right now, I'm talking, right? And live streaming right here, right? The first lab is due on Wednesday by midnight. Here's the full walkthrough, right? What else should you be doing? Reading the syllabus, checking out the resources on Canvas, reading our tips for taking an online course for you in the online sections, and for those in the in-person section, there's still very, very good advice in there. Right? Read the first assignment, due in about 3 weeks. Right? You don't have to get started yet if you don't want to, but at least understand what you're going to have to do. To help you on your journey, I've developed, this is completely optional, you're never going to hand this in. This is what's called a Gantt chart. It's a way of organizing your time, and it's a way of organizing a project development time. Basically what it is you've got weeks here. So for example, the red highlighted one, that's today, right? I've already planned out the first few phases here of the project and the first few weeks of the project. The rest you'll have to do on your own, right? You get the first, 6 weeks free? First 7 weeks free. Then you have to pay for the rest of them on your own. So the way that you would use this is, okay, well, what should I be doing right now? I should be reading and understanding the handout for assignment 1, right? It's not going to take me 3 days to do that. But I do need to stay on task here, right? If I get to day 4 over here and I still haven't read that handout, I have an indication that I'm probably behind. Once I've read that handout, though, I've only read half of it. All right, well, I'm 50% done with that. Okay, well, I'm on task now, right? Because the current date matches my burn down over here. It's not really a burn down chart. I'll just use that terminology, though, right? Okay, now I'm 100% done with it. Great, done with that. I'm ahead, right? On Wednesday, there's lab 1, right? Once I'm done with lab 1, I'll mark that as complete, right? Wow, I'm really far ahead now, right? Et cetera, et cetera. If you get to a future day, right, say, I don't know, the due date of the first assignment, right, and you've not designed your test cases, you've not had, your final rough draft of the code, right? You're just getting started on it 3 weeks from now. Right? You'll see that you're extremely behind using this Gantt chart here. You'll also note that the grayed out sections, what are those? Weekends. Right? I don't expect you to work on weekends. I don't expect the LAs to work on weekends. I work on weekends just to work ahead, but that's me. Right? So I have not scheduled anything for any of those weekends. Again, this is a Gantt chart. Feel free to use it. It's available on GitHub for this semester. Fill in your names, right, and get started with it. It's a nice way to keep track of your progress and know whether or not you're ahead or behind or whatever. And if you feel, well, okay, after I've done the first phase or so here, it didn't take me a full day to do that, or this task and that task, I don't see them as separate. I'm going to go ahead and change the Gantt chart. It's your Gantt chart. Do with it what you want, right? But otherwise, it's just an Excel file. Right? So, keys to success, keep up with your Gantt chart, or a to-do list or something like that. I have Gmail, and I really like their task list, right? Because I can set up recurring tasks. I can set up a task that needs to be done by a certain date, and it tells me when it's happening. Canvas does that to an extent. You should probably get periodic emails telling you this is due in the due date, right? Yes, no. If not, you can set that up, right? Let's take a look at Canvas since we've already looked at Piazza. Here is the Canvas section for 155, 156. Let's go over here to 156H. They're going to be exactly the same because they're both Monday, Wednesday, Friday classes. All of your labs are on Wednesday as well. But it's here's course information. Here's getting help. There's that instructor page with the office hour layout here. If you want to, you can go ahead and join us via Zoom. For labs, same one as labs and the same one as office hours. You can also go to the Student Resource Center if you want to. Your LAs will not be in there though, but if it's outside that time and you just have a general question, you need your password reset or something like that, go to the Student Resource Center. There are also several study areas throughout the campus that have been identified by UNL libraries. Otherwise, you have these very lovely people here. All of these are LAs that are here to help and want to help and have gone through this course at least once before. Right? So they know your struggles, they know the sticking points, they'll be able to help. Of course, you also have Piazza, right? 24/7 there. Maybe somebody's awake at midnight. I don't know. Anyway, everything is organized into, then there's some other resources here, just miscellaneous resources. Everything is organized into modules. For example, the module 1 is the introduction. It takes 3 weeks. We're going to bring you up to speed on Python and Java in the main section. What should you be doing in the first week? Well, there's lab 1, right? There's the syllabus that you should be reading. There's the Gantt chart that I just showed you. Did I spell it right? Yeah, I spelled it right. And then there's some videos on getting started, right? Getting set up, getting stuff installed, etc. In fact, again, there's a full video walkthrough on lab 1. Right? Week 2, week 3, as we progress along and along. Right? Things that are due that week. For example, nothing's due in that first 2 weeks except for the labs. There's assignment 1. It's due, all the assignments are due on Friday at midnight, Cinderella due dates. Right? No late work accepted. Right? Same with design documents. It'll be due that Friday. Assignment 2 will be due Friday, February 24th, right? Et cetera, et cetera. Lab 1, by the way, completely walks you through that grading process. Once you've developed your code, you're sure that it works on your own machine, you hand it in, it shows you how to hand it in, it shows you how to run the grader, et cetera, et cetera. All right, questions so far? No? Okay. Anybody coming from 155E or I don't think I did it in H. Anybody coming from 155E, there is no attendance policy. That is a guide rail that was used in Computer Science 1 to force people into good habits. Keep those good habits, whatever they were, because you made it, right? All right, so let's see, what else? Textbook. There is a free open source textbook. Unfortunately, it does not have an introduction to Java or Python. It also, unfortunately, does not have an introduction to object-oriented programming. But once we get to databases and SQL and beyond, it's my textbook. Right? It's a free open source textbook. It's just a downloadable PDF, right? And you can check it out. Right? Otherwise, there's required reading. There's no graded reading. If you're coming from 155E, we use Zybooks. We don't use Zybooks for this course. Again, another guide rail that is eliminated. Right? Otherwise, I've also got pre-prepared videos as we go along. These will also be posted on Piazza as a reminder that these resources are there. What else? YouTube, like I said, we're streaming right now. Hello, everybody out there. We're up to a huge audience of 4 people, but one of them is me. Right? So a lot more people will watch it after the fact, I'm sure. We've got our first question. Just to clarify, if we're coming from 155E, we start out in Java instead of Python, yes. You don't have to do both. If you want to do both, great, go ahead as a challenge, but definitely do Java, right? For the first 3 labs and the first assignment, right? Syllabus, that's over here, where is it? Nope. There we go. All right, I'm in dark mode, is that okay? I don't know, how does it look on a projector? You know what, all right, I don't think that's directional light. I can't just get rid of that one. So, and I don't know how to go and get out of dark mode. I don't know, is that okay? Yes, all right. Otherwise, I'll switch back to light mode later on. Anyway, the prerequisites for this course are Math 106. Why? Do you really need calc? Not really. Just general mathematical maturity. And of course, 155, you need at least one high-level programming language under your belt in order to tackle this course, right? C or better from 155A, E, H, N, T, whatever flavor you took, right? The description, there's the official course description, university policies, everything like accommodations for the students with disability center, to mental health stuff has now been offloaded to this central repository here that every syllabus now has at UNL. Academic honesty policy, services for students with disability, mental health and well-being. Remember that you do have that CAPS, counseling and psychological services. You have free access to that, an unlimited number of counseling sessions. 15 weeks, the final exam. Most of these will not pertain to this because, like I said, no exams, no quizzes, no summative assessment, right? what you should be able to do at the end of this course, you should be able to more easily pick up a new programming language, right? Now that you'll have 2, 3, 4 programming languages under your belt, right? You should be able to, oh, I want to learn JavaScript. Oh, okay, I'll go ahead and do that because I want to build a website of some sort. Oh, I want to do some game programming, so I'm going to learn Unity and C#, right? You should be able to pick those up way more easily, having 2, 3 different programming languages under your belt. All it is I know how to solve this problem now. All I need to do is look up the documentation. What is the equivalent of substring in C#, right? You've got to be careful though, because I was doing some scripts for the labs, by the way. I was doing some scripts in Python, and well, there's got to be a way of taking out a prefix in a string. And sure enough, there was. It was remove prefix. Oh, excellent. Great. And then I ported it over to the CSE server, which was running on Python 3.8 or something like that. And it was introduced in 3.9. So, damn it, I go back, I have to fix it, right? But just simply knowing how do I do this thing in that language, right? Then Google will tell you, right? But knowing how to do it in one language is the key. That's the starting point. You need to be able to, at the end of this course, you'll be able to recognize, use, and design and appreciate programs with an object-oriented flavor, design a database-backed application from scratch given a general problem statement, and be able to understand and implement basic data structures. I should use that data structure over there instead of that data structure over there, because if I use that one over there, it's going to take several centuries to compute versus that one over there, it takes several seconds to compute, right? In fact, that's it, literally in your first assignment, right? Not centuries to compute, but weeks to compute, right? Again, overall, Computer Science 2 is a continuation of CS1. There's the same overall idea that I gave before. With 15 minutes left. Again, here's the course delivery. Everything will be live streamed, assuming that everything works. So you'll be able to access older lectures. You can look at, I think I've been doing this for 4 or 5 years now. You'll be able to look at the first year that I did it, not on YouTube. I ported them to YouTube, but it was, I forget, it was the class capture systems, those things up there that I used. I forget what it's called, but I don't even know if they work anymore. Anyway, I'm using OBS now and directly streaming to YouTube. Okay. Labs, office hours, continuation of instruction. If classes are canceled for snow, I'll just live stream from home. So you'll still be able to attend remotely. Right? If you are feeling sick, COVID stuff or flu stuff or whatever, feel free to attend remotely. Right? That goes for the lab as well. You can just attend via Zoom if you want. Otherwise, there's the points. 9 assignments worth roughly 975 points. 13 labs, remember we dropped that one. And then some starter points here to make it all even out to 1250. Right? Nice round numbers are nice. Labs and assignments, no late work is accepted. So those Cinderella due dates, 1 second before midnight, they're strictly enforced by the system. Right? 15th week policy. I think that your final assignment is due during the final week, not finals week, but the final week of classes, dead week. There is no final exam, so once you've got that last assignment in, you're done for the course, right? Focus on your other final exams if you have any. Grading policy, you'll see who the grader is when we post a code post. It's got to work in the web grader, right? If it doesn't work in the web grader, it doesn't work, right? If that means that you misspelled something and it didn't compile, go back, fix it, give yourself enough time to address those issues. Again, for the honor section, you can ignore it if you're from the main section. We will cover things at a faster pace. So for example, we might be, I don't know, we might get done with Python early, and if we do, I don't know, we'll do some HTTP stuff or something is what I usually do. We'll do some multi-threaded programming is what things I've done in the past. We'll do JPA, Java Persistence API, whatever we get to and whatever we're interested in. Right? And again, one of the other things is that each assignment has bonus points. Those are required for the honors section. The best way to get help is, of course, go to Speak to an LA in person or via Zoom during help hours, or post to Piazza. Right? If you send me an email, that's a great question. I'm going to answer you here, but would you mind posting that to Piazza? Why? so that everybody gets the benefit of the answer, right? If you send me an email, one person is reading it, one person is responding. But if you post to Piazza, and anonymously, or at least anonymous to everybody else, 150 people are reading it, and at least one of them is going to be able to answer, probably quicker than I will, right? In fact, if there's a student answer, I'll just endorse that, assuming it's correct. I'll go ahead and endorse it. Right? The UNL Writing Center is available to you not just for this course, but for other courses. They can provide, like if you're writing a term paper in, I don't know, history of the United States or something like that, and you need help, the Writing Center is there for you. They're not going to edit things for you. They're not going to write it for you, but they will give you feedback, e-tutoring on it. Right? And tips for getting help here. Go ahead and read it at your leisure. Right? Otherwise, yeah. Those are, I think I've touched on all of those at least briefly. If not, look to Piazza because I'll be posting them later. With the last 9 minutes here, let's jump over here to, remind me later, is everything still working? Great. Well, it's slow. Okay, there we go. I just had to wake it up. Let's do our first Python program. All right? So my recommendation is going to be use the same CS50 IDE that you were using last semester because it's a full development environment. And it has Python support. Python support. If you want to install like a Python specific IDE, like PyCharm is popular. PyCharm, you'll find that everybody is oh so clever, and they'll just prepend everything with py, right? Keep that in mind. It's py. Why? Because Python, right? The entire language is a joke. It's Monty Python, right? That's where he took his name from. The language's name from. JetBrains, it's a free download. JetBrains charges for stuff. You will probably have to prove that you are a student. I don't know how arduous that process is, but if you want to, you can use PyCharm. Otherwise, I'm just going to use this for demonstration. Right? I can't get free stuff from them. I've tried before. Right? Anybody have any other suggestions coming from a Python background of what you've used before? No? Okay. Well then, let's create our very first Python program. Oh, I don't have a, okay, fine. I'll just create it right here. Touch demo.py. Right? Now, Python is an interpreted language. Unlike C, unlike Java, you don't compile it. You just start running it. Now, Python does have a JIT, which is a just-in-time compiler. So in the background, when you run your script, it will try to compile it so that it's faster. Usually it compiles to C code of some sort or something like that. You'll see it here in a second. But now let's go ahead and open up this file, demo.py. Right? Automatically, it's a Python file. As long as you start writing valid Python, it's Python. Right? If you start writing C, of course, like, I don't know, printf, hello, world. Right? That's not even a valid C program, much less a valid Python program. If I try to run this, demo.py, it's going to say, I don't know what the heck you're talking about. This is Python, this ain't C. Right? So the interpreter here, when you run it, the way that you run it is simply by typing Python and then the script that you want to run, and it starts running it. Right? It starts going line by line by line, executing it. If there's a problem down here on line 10, and there's no problems from lines 1 through 9, it'll execute 1 through 9, and then it'll choke and die in line 10. If there's a syntax error, generally that will happen, right? Although the preprocessor, there is probably the JIT preprocessor will probably find that out beforehand. So how do we print hello world in Python? Print, not printf, just print, right? Hello world. Looks very familiar here, right? Oh, sorry. No semicolons, right? You can put semicolons if you want. It looks weird. It's not Pythonic. Python will ignore them, right? So it'll actually run, but don't do that. That's bad Python, right? Okay. All right, let's go ahead and run this. Python demo.py. Hey, great. My very first program. All it took me was one line of code. Hey, that's much better than C, where you have to have a bunch of includes and the main and command line arguments and all that stuff, right? All that boilerplate stuff in C or Java, right? This is already better, right? that's not an argument for it, right? That's stuff that's automatically generated by your IDE or something, and it's a one-time thing, right? There is a main. I forget how to do it off the top of my head, but basically this is the main, right? If you want to create functions and put them off, we'll cover that later on, right? We have 5 more minutes. What else fancy thing do we want to do in Python before we adjourn? How do we print variables? Or how do we create a variable here, right? Int x is equal to 42? Nope. Python, like a lot of languages, are dynamically typed, right? You do not declare a variable, you just start using it. X is equal to 42. X is now magically an integer. Later on, if I want to say x, I don't want it being an integer, I want it to be a string, hello, right? That's okay, you can change it. Its type is dynamic. It dynamically changes depending on the value that you assign to it. Well, the other type that are supported is what? 3.14159, floating point numbers. There's no float, there's no double, there's only double, right? All floating point numbers are IEEE 754 floating point numbers, which don't worry about that. You have 16 digits of precision, okay? All right, let's go ahead and give these different names, Y and Z. All right, there we go. Let's run it. And by the way, it auto-saves up here. All right, there we go. Come on. Hello world. How do I print those things out? One way of doing it is just to print each one. Print X, print Y, print Z. Hey, it all works. What is it doing? It's one thing to a line, right? So what is this print actually doing? It's printing an n-line character for me. If you don't want to do that, I'd have to look up how to do that. I think it's like a end line equals none. Let's find out if that worked. Nope, that's not how you do it. Ignore me. I forget how to do it. I'm gonna have to look that up. But otherwise, it prints out automatically prints out an n-line character for you. If you want more, right? I really like double spacing. You can go ahead and put as many in as you want, just like any other language. And now there'll be 2 blank lines there, right? If you want to print stuff formatted, like say printf, like from C. In fact, every language supports printf style stuff. It's not even from C. It's from languages that predate C. Printf formatting, for example, %s for a string, %d for an integer, and %f for a floating point number, and then end the line, right? This is how you would do it in C, and also how you would do it in Java, just not printf. It would be like dot format or something, right? X, Y, and Z, right? This is not going to work in Python because printf is not a thing in Python. Instead, now Python 3 and recent versions of Python 3, you have what are called formatted strings. Here's a regular string. By the way, this is also a regular string. Single quotes, double quotes, it doesn't matter. As long as you begin double quotes, end double quotes, begin single quote, end single quote. It doesn't matter, right? I'm going to go ahead and go with my old school way of doing things here, double quotes. That may or may not be Pythonic, I don't know. I think Python encourages you to use single quotes. Do whatever you want, right? I'm going to format a string here by putting an F in front of it. And then what I'm going to do is I'm going to print out X is equal to X in curly brackets. And it's going to format that for me. Y is equal to Y, and Z is equal to Z. Right? Now I can print out and capture this into a variable. Message is equal to this. Print the message. And you'll see that it has been formatted exactly like that. Print is automatically inserting that n-line character for me again. Right? What if you want more significant figures? Unfortunately, you don't use the, you use basically the same thing, like dot. So colon, dot, and then the number of digits that you want, F. If you want to pad that out with 10, at least 10 or 20 columns, you can do that as well. This is going to be automatically formatted as a string. This is automatically formatted as an integer, but you can do it manually if you want to. Right? And this should work. Uh-oh. Nope. What is it for integer? Anybody? It should be D. I.
I think you're trying to do it to a string, Y to string.
Oh, is it? Yeah. Oh, you're right. This is my D. Right, there we go. D. Thank you. Right, there. If you want to pad it out with 10 columns, you can do that. If you want to pad it out with 10 columns but justify to the left, you can do that. Oh, that's not working. I forget how to do it justified left. But if you want leading zeros, I think hopefully this works. Yep, you can pad it out with a bunch of leading zeros, right? A whole bunch of little tricks that you can use here using formatted strings, right? If you've got more, right? Message is equal to message plus end of class, right? Because it is the end of the class, and print this out. You can do that. So tell me what's string concatenation? Plus, just like Java, right? By the way, yeah, more later since we're already done. All right, I'll see you on Wednesday before your lab, I think.